Okay, so we've already gone through linear functions when we talked about functions and relations. And that was where there was a constant rate of change. For every change in x, there was a constant rate of change in y. Okay, so here are 2 examples. So linear relations and functions form straight lines. These are actually application questions. You can see that is number of texts. So this was done a few years ago when you actually had to pay for your text messages. So you may not remember that because you're too young, but you'd have to pay every time you texted someone. So that added up. Okay, you guys would be broke if you had to do that now. Okay, but so this is cost for each text message, or cost for number of text messages. So the first one, the independent variable, usually we show it on the horizontal axis. So this is the number of texts. I'm still dealing with my old computer here because the other one's messed up. Dependent variable is the cost. That cost depends on how many texts you sent. Second function, so that's the amount of fuel, number of hours, so you can see that it's decreasing. So that would be the amount of fuel in a gas tank as you're using fuel in your car, okay? So the independent is the number of hours, and the dependent variable is the amount of fuel, I would say, in the tank. Okay. So remember, we calculated this. We've already done this. Rate of change is the change in the dependent variable divided by the change in the independent variable. So determine the rate of change of these applications. So I always suggest choosing a nice point on the x or y axis, if there is one. So this point here. And then another nice point. Luckily, we've plotted some for you. So I'll choose this one. So the change in the cost, basically you can draw a right triangle up and over there. Okay? So the change in cost is $5, and that's for 50 texts. So this is 5, this is 50. So the rate of change equals 5 over 50. Reduce that, that's 1 over 10. Now, in this particular application, it's representing money. So we use decimals for money. If it was just an x and y, we'd use fractions. But in this case, so 1/10 as a decimal is 0.1, and we're dealing with cost in dollars. So I'm going to put a 0 at the end. And it says include units, so that's the cost per text. So 10 cents for every text that you sent. Okay, back in the old days. Which is not as old as when I was young, because we didn't have cell phones when I was young. Units, so we've done that. The second one here. Again, anything on the x or y axis. So this is a good point. Here's another nice point. I'm going to draw a triangle. I always go from left to right, and that's what I want you to do whenever we're calculating rates of change. So leftmost point going down, we're going down 10, and to the right 2. Okay? So the rate of change, down 10, to the right 2, negative 5, and that is liters per hour. Okay. So in words, we would say decreasing by 5 liters per hour. So negative and decreasing mean the same thing, right? The decreasing is the word. Okay. right, so then it says, for the first function, as the independent variable increases, so as your x values are getting bigger, what happens to the y values? So in this case, as the number of texts increases, does the cost increase? Yeah, it's not going to get lower, that's for sure. So the dependent variable increases. And the rate of change is a positive number. Okay. Second one, as the independent variable increases, so as time goes on, as you're driving your car, the dependent variable decreases. The amount of gas in your tank is decreasing, and the rate of change is a negative number. Okay. So as you're going to the right, what happens? Are you getting bigger for the dependent? Then you have a positive slope. Are you getting smaller? Then you'll have a negative slope. So here's a bunch of diagrams just to help you. The change in the dependent variable is called the rise, and the change in the independent variable is called the run. You don't always want to have to say change in dependent, change in independent. So think about running. You're running along the horizontal, right? So this is your run. The change in the independent variable is the horizontal change. And the rise is, think about rising up, going up or down, right? So that's the change in the dependent. Okay, so rather than using all those words, we use rise and run. So from your left point to your right point, figure out what the rise is, then divide it by what the run is. Okay, that's your rate of change, or what we're going to call the slope. Okay, so that's going to have a positive value for this one. Here, your change in dependent, your rise is going to be going down. So negative, and then to the right, positive. So that has what we call a negative slope. Okay. So here is all the words. That's what we're really going to simplify it down to. So slope is rise over run. And then we're going to find a formula that you can use as well. Okay. M is used for slope. Not quite sure why. I didn't invent it. But that's what is understood to be the slope. And lowercase m. Yesterday we did midpoint, which is uppercase. This is lowercase. Okay? So this is a ramp. Maybe it's made out of cement. Okay? What is the slope of it? So that's the rise over the run. So here's your ramp. So from left point to right point, what's the rise? So we're going up and across. Well, we're given this. That would form a rectangle. So that's going to be 4, same as over here. And this is going to be 17. So the slope will be 4 over 17. You leave it as a fraction in lowest terms 99% of the time, unless you're told to round it. Okay? Roof of a house. What is the slope of the left side of the roof? So take a look here. This is a big triangle cut in 2 halves. We're not told for sure that it's cut in half, but assuming most roofs, they want to make them symmetrical like this. So if this whole distance is 18, then this would be 9. Okay? And so from this left point to the top, we're going up and to the right. Well, that vertical rise will be the same as this. So that's going to be 6. And your run will be the same as this, which is 9. So your slope is 6 over 9, which reduces. Oh, sorry. 2 over 3. Okay. Now, we did say the left side. If we looked at this, it would be negative. In real life, if a builder, they're going to keep it positive and just rotate, right? So that they know which direction. So really, the positive and negative come into play when you're graphing on grid paper. All right. Here's another application. So this is a building, okay, built vertical to the ground. Here's your ladder. It's 5 meters. That is the hypotenuse. That will never have anything to do with your slope. Okay? Slope only has to do with vertical and horizontal. In any case, it says, determine how far the bottom of the ladder is from the base of the building. So that would be this distance. I'm going to call it x. That we don't use slope for. That's a distance. This is a 90-degree triangle, so use Pythagorean theorem to find that side. So you do that quickly. Okay, so the slope, distance x, Pythagorean theorem is 3. Remember, we talked about Pythagorean triples the other day. 3, 4, and 5 satisfy the Pythagorean theorem. 5 is the longest side. So really, you may have known that that was 3 without even doing the using the Pythagorean theorem. Okay, so now the slope of the ladder. So from the left to the right, we're going up and across. So we're going up 4 to the right 3. This equals 3. So the slope here is 4 over 3. Okay. So next page goes through basically how to calculate slope. So there's not really it's the same line segment in each column there. Okay, so we'll look at those. So there are 2 line segments. They're plotted on grid paper. Okay, and so to calculate their slopes, it says start at the left endpoint. That's what you always want to do. You read a book from left to right. You read a sentence from left to right. You spell from left to right. So looking at this, going from left to right, how are we going to get there by vertical and horizontal? Well, we have to go up. Then we're going to have to go across. So first you find your rise, then you find your run. For this one, left to right, we can't get to the right-hand side by going up. We have to go down. So we're going to go down and then to the right. Okay, so you're always going to end up going to the right. It's whether you go up or down to start. So up and then horizontal line across. So now let's fill that in with the values. So up 3, to the right 3, 6, 7. Okay. Here we're going down 1, 2, 3, 4. To the right 6. So we're going to calculate those slopes underneath. So here the slope is 3/7. Can't reduce it. Here the slope is -4 over 6, which reduces to -2/3. Okay? Down and to the right, negative. So that confirms that you should have a negative slope. Okay? So, right-hand side of the page just confirms those, positive and negative. So all of the line segments you've seen so far were oblique, so diagonal lines. Oblique line segments are segments that are not horizontal or vertical. From question 4, you saw the slope of an oblique line could be positive or negative. Without doing any calculations, how can you determine just by looking at an oblique line whether it be positive or negative? So if we're thinking about going from the left point to the right point, if the line goes up and to the right. Okay. For negative slope, if the line goes down and to the right. So if you start, at the leftmost point, you're either going up or down, and then to get to the right, you got to go to the right. So. Okay, so now we have horizontal line segment there. So what is the rise? Well, from the left point to the right point, there is no rise. It's 0. The run here is 3, 6, 7. Okay. Well, rise over run then. 0 over 7 is 0. So the slope of any horizontal line is 0. Okay? Memorize it if you need to, so you don't have to calculate it each time. Vertical line, the rise here is 3. The run is 0. So slope would be 3 over 0. Well, can you divide by 0? No. So we call this undefined slope. Now, sometimes you might hear it called no slope. And that's okay as well. I tend to use undefined because sometimes students get mixed up between 0 and no. So 0 slope is horizontal. Think about running on a horizontal road. You're not going up at all. 0 slope. Vertical line, we call it undefined slope. You can't really get up vertical line, right? You need help with pulleys and all that kind of stuff. So there's no slope on that. Okay. So to summarize, a line segment can be oblique, horizontal, or vertical. If it's oblique, as you read from left to right, it can go up or down. For each, what can you say about the slope? So here, we don't know what the value is, but here we're going from left to right, it's going up. So that's a positive slope. From left to right, it's going down. So that's a negative. Here, it's not changing at all. So that's 0. And here, it's a vertical. So that's undefined. Okay, so that's kind of your summary of all the types of lines. Okay. So now let's do some calculating. All right, so if you have a line on grid paper, again, you don't need a formula. You're just drawing a right triangle to get those values. So slope of AB, starting at A, we have to go up and to the right. So we know it's going to be positive. 1, 2, 3, 4, 5, 6, 7, to the right 3. CD, from the left to the right, we go down and to the right. So down to the right 6. And reduce it. Slope of EF, well, it's a horizontal line. We just said all horizontal lines have a slope of 0. And GH is a vertical line, so undefined. Okay, next one. You have a whole bunch of points on the same line, and it says find the slope between each of the pairs of points listed. So sometimes we use subscripts. So here, slope of AB, that's what that means. So from here, we go up and to the right, so that's 2/3. From B to C, it's the same, 2/3. From A to C, that's going to be 4 over 6, which reduces to 2/3. Okay? If all of these points are on the same line, the slope is going to be the same when it's reduced. Okay? It's got to be proportional. That's what makes it a straight line. Okay? Otherwise, it would be bending off. Okay? AD would be 2, 4, 6. 2, 4, 6, 8, 9. Okay. So this is just a bunch, and then BD would be 2, 4 over 6. Okay. So what is true about all these slopes? They are equal. Okay. So any points on the same line, like this, we call them collinear points. And the slopes between collinear points are equal. Co means together, linear means on a line. So collinear are points on the same line, and they will have the same slope between them. So if you pick any 2 points on this line, what will be the slope of the line segment that connects them? 2/3. Okay? May not start out as 2/3, but it will reduce to 2/3, even if you have decimals or fractions. Okay? And so here's where it summarizes it. A, B, C, and D are collinear because they lie on the same line. If points P, Q, and R are collinear, what conclusion can you make about those slopes? That they are all equal. Okay, right-hand side of the page. Now we're going to practice drawing some lines. So slope won't tell us enough about a line. We always have to have a point. So it says draw the line that passes through the given point with the given slope. Okay, so we have to plot the point first. So -5, 6 with slope of -2/3. So the negative is out front. You can use that either with the 2 or with the 3. I always start with the numerator because that's the rise, right? So I'm going to go down 2 and then 3 units to the right and put a point. Now you might stop there, but I don't want you to. I want you to fill up the grid paper with as many points as you can, because really if you use just that with a straight edge, you might be a little bit off as it extends out. The more points you have, the better line that you can draw. So I'm just going to go from there, 2 down, 3 to the right. Then 2 down, 3 to the right. Then 2 down, 3 to the right. Okay, you can even go up 2 to the left 3, because this is the same as 2 over -3. That's just not in proper form, right? But that in the action of graphing, it's the same. So then get a straight edge out. You're going to buy a ruler or a straight edge if you don't have one for this unit. You're going to put arrows, arrows on the end. Come on. Okay, because the line keeps on going forever. Right? Next one, -7, -2. Slope is positive, so that means up +5, 3, 4, 5. To the right 4. Do it again if you can. 3, 4, 5. To the right 4. And that's really all of the space that we have in there. Okay. Then the next one, -3, -8. Go down a little bit. So -3, -8. Slope of 2. If it's an integer, that really means it's 2 over 1 in terms of rise over run. So we're going to go up 2 to the right 1, up 2 to the right 1 again, as many times as you can, so that you get a nice line. 2, 8. We go back up a little bit. 2, 8 is here. Slope of negative 5, again, that's negative 5 over 1. So down 1, 2, 3, 4, 5 to the right 1. 1, 2, 3, 4, 5 to the right 1. 1, 2, 3, 4, 5 to the right 1. I'm a little bit off there. Better. Arrows on the ends. Okay. Then next one, 5, 4. Slope of 0 is a horizontal line. So you don't have to draw any more points. You know it's a horizontal line. And you can just graph that line for when y is 4 there. So I don't really need to draw any more points. I'm just going to graph on that line. Okay, that is E. And then F, 7, negative 4. Okay, and undefined slope. So that's a vertical line. Again, you can plot more points anywhere along there, but you can easily see, because we've got grid paper, that it's on this line here. Okay. Right, so that's a bunch of lines. We have to have a point in order to use the slope. Okay, so in order to save a little bit of time in question 11, we're not going to do all of them. We're going to do 1/3, 1, and 4. Okay? They're all positive slopes. So we're just going to graph 3 of the lines. So, goes through 0, 0. You have to have a point. Slope 1/3, up 1 to the right 3. Up 1 to the right 3. Notice how, if I'm using the positives, I only get points to the right. So I could also show that as -1 over -3. Right? That's not in lowest terms, but in terms of actions to get slope, we can go down 1 to the left 3. Down 1 to the left 3. Down 1 to the left 3. So that we can fill up our grid paper. You always want to fill up your grid paper. Oh, what am I doing here? There we go. Okay. So, that is slope of 1/3. Then slope of 1, remember we're not doing all of them. Slope of 1 is up 1 to the right 1. That's a integer, right? So it's 1 over 1. So you can get lots of points here. Or you can go down 1 to the left 1. So basically, slope of 1 cuts each quadrant in half diagonally. Okay. And then slope of 4. So 4 is like 4 over 1. So up 4 to the right 1, up 4 to the right 1, or down 4 to the left 1, down 4 to the left 1. Okay, all of the slopes are positive. So as we go from left to right, the line goes up. As the size of the slope increases, so this blue one was the smallest, then the green, then the red. So the actual values of the slopes were increasing. Take a look at the steepness of the line. So as the size of the slope increases, the line gets steeper. You're climbing a hill. This hill is way easier to climb than this one. This is more steep. The slope is bigger. Okay. Now for the next one, same deal here. We're just going to do 3 of them. These are all negative slopes of what we did in the one above. Okay, so there are those 3 that I asked you to graph. You can do more of them if you want. This was the negative 1/3, the blue one. Green was negative 1, and red was negative 4. All of those slopes are negative. As you go from left to right, the line goes down. Now, as the size of the slope of the line increases, what happens to the line? So think about negatives. The negative 4 is the smallest. As it increases to negative 1/3, what's happening? The negative 4 is the red, and then the green, and then the blue. So it's actually, red, green, blue. So it's going from steeper now to less steep. When you're dealing with negative slopes, as it increases, it gets less steep. Okay. So those are just properties, things to think about when you're graphing to have a sense of what your line's going to look like. We're going to be learning all about equations of lines and graphing equations of lines. And so you need to have an idea of what it's going to look like and if you're doing the right thing. So turn to the next page. I'm going to talk about x and y intercepts with a P. So there's a line. Okay, so really we should have arrows on the end of that. It intersects the x-axis here and the y-axis here. State the coordinates of these points. So you can just label them right on your graph. The coordinate there, coordinates, 0 for x, negative 4 for y. Here, 6 for x, 0 for y. Okay. Now, in terms of calculating the slope, you don't have to use a formula. We'll get to the formula, but we're really going up and to the right. Remember, collinear points all have the same slope. So I'm going to choose this y-intercept, the left point here. I'm going to go up 4, then to the right 6. And it reduces to 2/3. Okay? So things to remember, if you have a line that passes with has an intercept that's positive and an intercept that's negative, the slope will be positive. So here a negative y-intercept, a positive x-intercept. The slope is positive. If they're both the same, the slope will be negative, both the same sign. In this case, they're opposites, so it'll be positive. The x-coordinate of the point of intersection of the line and the x-axis is called the x-intercept. Notice it's got a P. So when you're asked for the x-intercept, you just state the value. You don't give the coordinates. If you give the coordinates, it needs to have asked you for it. Oops, sorry. Then here, the y-intercept is negative 4. So now, draw a graph with an x-intercept of 7 and a y-intercept of 5. So both of those intercepts are positive. So if you can remember that, you know that your slope will be negative. So if I join that up, I don't have enough information to plot more points at this time. So I'm going to do the best that I can with those 2 points. Arrows on the end. Okay. What's the slope of this line? So again, you can go down and to the right, because you don't know 2 nice points. So down 5, to the right 7. So if these are both positive, my slope will be negative, and that is -5/7. So you're just really taking the ratio of the intercepts and changing the sign. Okay. So we can then graph these if we wanted to, but hopefully we'll be able to figure it out. So what kind of slope will we have? Positive, negative, 0, or undefined. If we have a line segment, so if you want to draw a little sketch of an XY axis, then it says a line with a negative x-intercept, so somewhere over here, and a positive y-intercept. So what I said, if one's negative and one's positive, the slope will be positive. So up and to the right. Okay, so that's going to be positive. If you have a negative x-intercept and a negative y-intercept, so they're both the same sign, okay, then you're going to have a negative slope. The ratio of the intercepts change the sign. A line with no x-intercept. So these all have x-intercepts. Well, no x-intercept would be a horizontal line like that. Okay. Now, if a horizontal line was right on the x-axis, then it would have an infinite number of x-intercepts, not just one. Okay. And not 0. It'd have an infinite. So really, a line with no x-intercept is a horizontal line and has 0 slope. This line here that has infinite x-intercepts also has 0 slope. Okay? So 0. And then a line with no y-intercept would be something like that. Never going to touch the y-axis. It's parallel to it. So it has no y-intercept. Now again, if that was the actual y-axis, it would have infinitely many. In any case, this one has is undefined slope. Okay, so we want to get to coming up with the formula that we can always use. Okay. So on the right-hand side, there's a line segment. Dependent variable is going to be y here. It's always the vertical. And independent is x. So the rise is the change in the dependent variable, which is the change in y. And sometimes it's abbreviated to delta y. That Greek symbol delta means change in. So change in y. Using the graph, we start at our left point. Our rise, we've got to go up. And then we're going to go across to get to B. Okay? So the rise here is 4 units. Then the run is the change in the independent variable, okay, which is the change in x. And similarly, we can use delta x. So it's like a triangle. The Greek symbol delta is a triangle. The run there is 3, 4, 5. I'm just going to minimize this a little bit. That didn't do much. Just a sec. Okay. So coordinates of the endpoint. So A is 3, 2. And B, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Okay. So how can you calculate the rise? The rise we said was 4. Okay, looking at the y values, how do we get 4 from 6 and 2? Subtract. Okay, so we subtract. So 6 minus 2 is 4. Kind of like what we were doing for distance, right? Then for the run, we know it's 5. Well, 8 minus 3 is 5. So we're subtracting the y values, subtracting the x values. So, in general, expression for the y's, rise would be y2 minus y1. Okay, for the x would be x2 minus x1. And so that's really going to lead us to our formula. Okay, so slope is rise over run, which we can say change in y over change in x. We can say it as delta y over delta x, or what we're going to most commonly do is y2 minus y1 over x2 minus x1. That's what we're going to give you on a formula sheet. Okay, m equals this. Good idea to memorize it for yourself, though. If you're given the line on grid paper, don't use the formula. Plot 2 points, rise over run. It's when you're given no grid paper and you're given the points that you use the formula. Okay, so slope here. So here, you could label this x1, y1, and this is x2, y2, just so you remember which is which. And so y2 is 2 minus y1 is 6 over 5 minus negative 3. And simplify that. So that's negative 4 over 8, which reduces to negative 1/2. Okay? So we show the negative either up top or out front. We don't tend to show it in the denominator. That's not lowest terms. You might use it like that to get points on your graph, but either one of those. And then just switching the order. So if I chose this as my second point, so if I did x2, y2, x1, y1, then my slope would be 6 minus 2 over negative 3 minus 5, which reduces again to negative 1/2. So it doesn't matter. You just can't switch them between, right? You can't go y2 minus y1 and then x1 minus x2. You've got to be consistent. Otherwise, you'll get the wrong sign. Okay, so I'm going to give you a few minutes to do question 20 using the formula. Okay, so there are all the slopes of those 6 sets of points. You'll notice that in D, if you use the formula, you get 0 in the denominator, which means the slope is undefined. If you take a look at the actual coordinates, you'll notice that they have the same x values. Okay, so that means if they have the same x values, remember, they're going to be 2 points on a vertical line. So if you see that right away, you don't have to do the formula. Okay, you can just state that its slope is undefined. Similarly over here, if you take a look at these points, these have the same y values. So those are points on the same horizontal line. So if you notice that, then you can just write the slope as 0. Okay? You don't always have to use the formula. Okay. Next one is thinking back to those collinear points that we were talking about. So if P, Q, and R are collinear, then the slopes between P and Q, Q and R, and P and R are the same. Use this to determine whether or not the following are collinear. Note that you only have to show that 2 of the slopes are equal. So if we have P, Q, and R, so that slope would be the same as this slope, which would be the same as the whole slope. Okay? If they were different, okay, then maybe it would look like this, right? P, Q, and R. Your slopes would be different. You only have to find 2, so this slope here and this slope here, because you're using that same point. So you know that they are connected. If you had a slope like this, PQ, those might be the same, but this wouldn't be point Q. Maybe it's T. So those wouldn't be collinear. You couldn't determine that. You'd have to find the slope between these two. But that's really 4 points. So any 3 points, you just have to calculate the slope between 2. So 2 times here. So here in DEF, I'm going to find the slope of DE and then the slope of EF. Okay? So you do that. Okay, so when you calculate the 2 different slopes, you'll notice that the values are the same. So slope of DE equals slope of EF. Therefore, points are collinear. Okay. And then I'm going to get you to do B on your own. We're not going to spend the time on that one. Okay. Next one, we have 3 points as well, but we don't know one of the coordinates. So it says determine the slope of AB, then write an expression for the slope of BC. It'll be in terms of x. And then we're told that they are collinear. So that means the slope between A and B and B and C and A and C, all of those have to be the same. So if we've calculated between A and B, and we've got an expression between B and C, those have to be equal to each other, and we can solve it. So slope of AB, -3 minus -4 over 5 minus 2. Reduce it. Well, actually, it is reduced. Let me simplify that. Slope of BC would be 1 minus -3 over x minus 5. And simplify that. Okay, you're going to have a variable in the denominator. And what can you say about the slopes of them? They are going to be equal. And so if they're equal, then we're going to solve that equation. Kind of helpful that we just finished, a couple weeks ago, the rational equations concepts. Okay, because that's a rational equation that you can solve. So you get x minus 5 equals 12, so x equals 17. Okay, so in 24, Now we're given just 2 points, and we're actually given the slope. This is even easier than the last questions. So we're told what the slope is, so we know the slope of AB is 1/2. And now use your formula, so y2 minus y1 over x2 minus x1. Okay, and that's your equation to solve. So simplify if you can, so that's 4 over x plus 1 equals 1/2, and then again, multiply both sides by the common denominator. And really, that divides out, the 2 divides out. So you're left with 8 equals x plus 1. So x equals 7. If you have grid paper, you can figure some of these out. But on a written response part of the test, you're going to be asked to show work, algebraic work, which is this. So here, this would be slope GH equals -2/3. So slope of GH would be 4 minus 0 over -2 minus x. Now you could factor out a negative, but we don't need to. This is a pretty straightforward in terms of these are never going to be the same. So you can multiply through. Sometimes when we do this, we call it cross multiplying. So if that is how you want to think about it. But really, we're multiplying by 3 times -2 minus x on both sides. 3 times 4 is 12. -2 times -2 minus x. So x equals 4. Okay, I'm going to leave the next one for you to do. Okay, so we're going to do 25 together. This will be the last one. You can finish 26 on your own. So a line segment with a slope of -1/2 has one endpoint at 0, 4. If the other endpoint is on the x-axis, determine its coordinates by graphing or the slope formula. Sometimes you can do it either way, again, depending on how the question is being asked. So here we want to graph 0, 4, okay, with a slope of -1/2. We know it has an endpoint on the x-axis, right? So use your slope, just like we were doing that whole question. We have a point. We're going to go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2, until we get to the x-axis. And that's where we get at 8. So by graphing, the coordinates on the x-axis, determine its coordinates would be 8, 0. Okay, right there. Now, using the slope formula, so this is like saying if I call this point A and this point B, then we know this is basically like the chart above. Slope of AB is -1/2. Okay? We have our point A is 0, 4. Our B, well, what is B? We know what it is, but we have to pretend that we haven't done it by graphing. We know it's on the x-axis, okay? So right now it's x2, y2. That's too many unknowns, right? We need to know one of these. Well, if we're told that it's on the x-axis, what's the y value? 0. So really, B is x2, 0. So now, now our slope of AB is y2, which is 0, minus y1, which is 4, over x2 minus 0 equals negative 1/2. So if I simplify that, I get negative 4 over x2 equals negative 1/2. Okay. You can multiply through, or this is kind of a proportions question, right? You don't even have to do that. So this is negative 1, that's negative 4. So really, I multiply top by 4 and bottom by 4. So x2 equals 8. Okay. And that's what I got there. So you can finish 26 on your own.